Question 17. What is the purpose of a diode? Is it to produce a potential difference, to reverse the direction of the current, to prevent a current from going backwards, or to measure the current in a circuit? Well, D sounds like it's describing an ammeter. A sounds like it's describing a power source. B, reversing the direction of the current, isn't something that we've really covered. So the power supply produces a potential difference. A diode cannot reverse the direction of a current. Ammeters measure current. And a diode is like a valve that blocks a current from going in a particular direction. So C is the correct answer. Diodes are like valves that only allow current to flow in one direction. They'll change an AC signal going back and forth into a DC signal that goes blank and forth and blank and forth. So half the time there will be no current, simply because half of the AC signal is being blocked. Question 18. What is the nature of the Australian power mains? Is it 240 volts DC, or AC moving back and forth at 50 times a second, AC moving back and forth at 100 times a second, or AC moving back and forth at 150 times a second? So right away I'll tell you that it's not going to be DC. DC is not used for any power mains because it's very difficult to transmit at long distance. You always lose more energy than it's worth. So out of these three, what we have to figure out is what frequency the generators transmit at. In other countries, they sometimes transmit at different frequencies. In the Australian power mains, the AC power source moves back and forth 50 times a second, which means that we have a 50 Hertz power supply. Question 19. Name the different components in this electrical circuit and draw arrows to indicate the direction of the conventional current. Now we have 5 different parts to this circuit. We have a power supply, we have 2 devices that make measurements, we have a globe, and we have another resistor. So how shall we label this? It might be something like this. We have a DC power source, an ammeter, a globe, a resistor, and a voltmeter. Remember that ammeter and voltmeter aren't that easy to forget. Ammeter is represented by A, and voltmeter is represented by V. Should be fairly simple. Now what about the direction of the conventional current? So this is opposite to the direction of the electrons. If we are going opposite to the direction of the electrons, we flow from positive to negative, right? Now, if our DC power source looks like this, which end is positive and which end is negative? That's right, the positive end is bigger. So we're going to have something that looks like this. The large end is the positive end of the power source, and so current flows away from that, around the circuit like this, up through the resistor, back through the globe, and then to the negative supply. Now you'll notice that I don't have any current flowing through the voltmeter. That's because voltmeters have a very large resistance, and current doesn't usually flow through them. We'll learn a bit more about why that is a bit later. Question 20. In this circuit diagram, draw an AC power source at A, a switch at B, and a variable resistor at C. I'll give you a moment to complete your diagrams. Right, that should be time enough. You're able to pause the video, right? So, our AC power source might look like this. A circle with a little sine wave across it to show that it varies. A switch at B will look like this, which we can open and close to allow current to flow through the circuit. And finally, a variable resistor at C, which looks kind of like a resistor but with one change. We draw a little arrow across it to indicate that we're able to change how large the resistance is. Question 21. Classify the following circuits as AC or DC. The current produced by a battery. Now, AC or DC? The battery produces a constant current due to the chemical reaction only acting in one direction. So, It's a DC power source. B. What is the current in the Australian power mains? Well, we know that DC is very difficult to transmit over long distances. So if we want long distance power lines, we're going to need AC. What about the current passing through a diode? Remember that a diode is a special device that acts like a valve. It only lets current flow in one direction. That means it can't vary back and forth, and it can't be alternating. That means that even though the current isn't constant, it goes forward and stop and forward and stop. We still call it a DC current because it never goes back. How about the current powering a smartphone? So what's the power supply in a smartphone? Is it connected to the Australian power mains all the time? Well, no, because then you wouldn't be able to carry it with you. Instead, it uses a battery, and a battery produces direct current. Finally, what's the current powering a fluorescent light? Does a fluorescent light use a battery? Well, I've never seen one that has. So it must be connected to the Australian power mains, and this means that the current going through it is AC. So that's the end of the questions. In this section, we've learned about electrical circuits, which are simply circuits of conducting material through which electrons or other charge carriers flow. And we've learned about how to draw circuit diagrams with various components like power sources, resistors, ammeters, and voltmeters.